Okay, welcome to the first video of subtopic 2.1, types of materials, and it's a very first video for topic 2, combination of atoms as well. In this video, we'll be covering the first item in the table. Materials can be classified according to their structure and bonding into 4 types of substances, and we'll just look at basic properties of them as well. All right, let's look through that. Okay, so types of bonding. We'll be looking at metallic, ionic, and covalent bonds to start with. Now, it's called bonds because they are the strong forces of attraction. Without atoms and particles attracting each other, you won't have any bonds. So even though it's making a thing, like let's say water molecule, H2O, and that's the structural molecule which signifies that it's water. But without bonding between H and O and oxygen to another hydrogen, you won't see that molecule happening. So we are looking at that first. So as I said, these 3 types of bondings happen between atoms, and they're called primary bonds because 1, it's strong, as well as it happens between atoms to make bigger compounds or molecules, and it's connected to that directly. Forces of attraction, there are 2 types of it. First one is intramolecular force, and it happens within the molecule, and the other one is intermolecular force, which is happening between 2 molecules, or between more than 2 between molecules. So think this way, if you have got water molecule, H2O is the formula. So you would be looking at something like, sorry, I should have made that before, H2O. So that's one molecule here. And if you have this molecule, the bond that happens between oxygen and hydrogen is a intramolecule. Okay, so that would be intramolecule. If you had more than one water molecule, what you can also expect is that the intermolecular forces occurring. So this is one water molecule. Now, because oxygen's a lot more electronegative, so that wants to pull more electrons, or something that's positive would be being pulled towards it too. So electron clouds bigger here, so that's why hydrogen from other molecule would be pulled towards. That's why water is a bit viscous. They've got pretty good surface tension because they attract, molecules in water attract each other, and the attraction that happens between H and oxygen here are called intermolecular force. You'd have heard the word internet and also the intranet as well, probably. Now, internet happens between your computer to, say, Google's computer or server. There is really just computer, and the communication is happening between separate things, right? That's why they're called internet. Okay. Whereas if you are looking at your network drive, like H drive or J drive, that exists within a school server, you are accessing from your computer to the server which lives in the same organization. That's why it's called intranet. Okay, so that's one example I can give you. Inter is outside, intra is inside. Now, those primary bonds, so ionic bond, which happens between metal and non-metal atoms. If it's covalent bond, it happens between non-metal and non-metal atom, just like water. Yeah, okay, so I was going to say there, it causes different types of structure as well. Okay, I will talk about structure in the next slide, I think. But yeah, it will have different shapes, different structure, cause 2 different structures. And lastly, metallic bond. It happens between metal and metal. And types of chemicals, types of bonds all symbolized in that image as well. For ionic, it requires electrons to be transferred. So one is donating electron to another, whereas covalent, electrons are being shared, just like sharing meal. And metallic bonds, as long as they gain one electron, they don't mind passing that along, which causes physical property of conductivity in electricity as well as heat. Okay, let's talk about the structure that I slightly mentioned. Firstly, we can have what's called lattice. Now, lattice is a continuous and large structure. Think of this lattice that you can find in a garden. You can find a continuous pattern there. That happens between something that's positive, something that's negative, and something that's negative is surrounded by other positive particles, kind of like that. So things like sodium chloride, you can grow a crystal, don't you? And that's the reason why, because it makes lattice. Ionic lattice can happen, covalent lattice can happen, metallic lattice can happen as well. That's three different types of structure that I mentioned in the things to be covered in this video. Another structure type is molecular structure, which is not continuous and it's much smaller. Lattice can become even visible size to your naked eyes, but molecules would not be as big. Covalent molecules can happen, and that's the only molecular structure that you need to know. So there you go. There are 4 different types of structure due to different types of bonding existing. I just wanted to make sure that you know the difference between molecule and compound. Now, molecule can be things like oxygen molecule, diatomic molecule that is there, or carbon dioxide. The carbon dioxide is a molecule, but the oxygen gas is not compound. Both are molecule, but oxygen gas is not compound. Why? Oxygen molecule only has one type of atoms, whereas carbon dioxide have got 2 different types of atoms. So it's compound and a molecule, but oxygen gas is not a compound. It's still element, but in a molecular structure. Hope you got that. Okay, let's talk about structure of ionic bond. As I mentioned earlier, ionic bond occurs between ions, so permanently charged particles like sodium and chloride, or say ammonium ion and sulfate ion. They are always going to be positively and negatively charged. Therefore, what do you expect? Force between particles is very strong, intramolecular, and I explained why as well. Electrostatic charge is static; it's never go away. That causes a property, physical property, to be quite strong. So melting point is high, and boiling point is also high. Tm and Tb stands for temperature of melting, temperature of boiling. You might start seeing these shorthand soon. Structure also is going to be continuous and large. So that's for ionic bonds. Now, covalent one can come in 2 different types. If it's continuous structure, so the lattice structure, for example, diamond or quartz, which is SiO2, you can only see Si and O, both are non-metals, so it's going to be non-metal, covalent bonds as well. But it's going to be much larger structure, like that one. Now, forces between particles would be strong intramolecular bond, okay? Strong, because electrons are shared and it's gonna stay there. It's going to be really strong, and you can see that from property of diamond. I'm not sure if you have ever hammered a diamond, but that's one of the hardest element that you can get. That also causes high melting point and boiling point, just like ionic structure, and structurally, it's continuous large covalent lattice. Yeah. Now, covalent bonds can also cause molecules to be, the smallest unit to be small, which is called the molecule structure. The forces between the particles, so I'm talking about this particle and this particle, that will be intermolecular structure, intermolecular force, which is happening always between the molecules, which means compared to covalent continuous structure, it will be much lower boiling point and melting point. Okay. Structure is then going to be molecule and small. Chromosomes, that's one of the biggest, I guess, molecules or part of protein. You can think that as molecules, but that's still much smaller compared to a grain of salt. Grain of salt would be continuous structure. Okay, so one thing that I have to point out is that within the molecule, yes, there is intramolecular force that's holding water molecules as water molecule. However, that itself can be also broken by some electricity or heating up. Like if you pour water into oil, the boiling hot oil, it just becomes hydrogen gas and oxygen, so it burns, just explosion happens. The last one here that I wanted to go through was the metallic bond. Forces between particles will be strong, intramolecular, because electrons are being shared and it's going around everywhere. And those electrons are called free electrons. That causes high melting and boiling point for all the metals. Hopefully you can imagine that. And it's going to be continuous and large structure. And metallic bonds, as I mentioned there, it happens due to free electrons. Now we'll stop there. And there are the structures. Hopefully you got the 4 different types of structure and their property. Okay, I'll see you in the next video.